This is video 2 in electron configuration. So we now understand the general things that go behind where an electron is likely to be. It wants to maximize its closeness to the nucleus, but it also doesn't want to get too close to other electrons. So the distribution in electrons in the orbitals is trying to ensure that each of the electrons has the lowest possible over potential energy that it can. So there are a couple of rules. It's kind of like the way that people have these unwritten rules about going into a movie theater, right? Most people want to get as close to the screen as possible. Most people want to get toward an aisle seat rather than a middle seat. The middle seats are the ones that are least likely to be filled up if they get filled up, right? So again, electrons also follow those rules within an energy level. So the energy level, they want to be as close to the nucleus as possible. So they will fill in the first energy level before the second energy, before the third. So they are only going to move to the next energy level in general when the force repulsive gets too high. Also within an energy level, the order of filling goes, you want to fill the s orbital first, then the p, then the d, then the f. Simplest orbital, lowest potential energy before you go into these really weird shapes. Another thing to remember is that the d and f orbitals, because you have such a high electron density when you start packing them in, have a really high potential energy. So oftentimes it's easier to go further from the nucleus a bit in order to fill this up. So 4s orbital fills up before the 3d orbital. So part of what I like people to imagine is a crazy building that looks like this. And there's a stairwell right here, and the stairwell is only on one side. And this is where you have to take a standardized test, right? So you're coming in really early in the morning, and it's open seating. You're not assigned a room. So the first person who comes in, because it's early in the morning, will definitely want to go into this room, the first room, that's right by the stairwell. Second person comes in, they're like, woohoo, there's another seat that's there, they'll fill in. Third person that comes in, well, each room can only hold 2 people. Like, oh man, this is filled, so they go up to the second floor into the room right next to the stairwell. They're not going to go up to the 7th floor. It's really early in the morning. So what starts to happen is that you can start to predict if I have the 11th room, or if I have 11 people signed up for this test, I can pretty well predict where I should place the tests in order to ensure that I don't have to run around and try and find people, because I can predict where they're going to be. So on the 2nd floor, I have 2 sets of room, the ones that are right next to the stairwell, and then 3 sets of partially down the hallway room. And these are P rooms. So I can fit 1, 2, and then here each one can fit in 2 people, so that's 6. If I have 2, 4, 6, 8, 10, more than 10 people, the 11th person, that 11th person will probably be on the 3rd floor in a room right next to the stairwell, so in an S-shaped room. So by using this analogy, you can start to understand where we can predict electrons will be. Not a specific one. So if you said, where is like Tony going to be in this situation? I don't know. I just know that this person will probably be in one of these rooms. Now, as you'll notice, because of the weirdness of this building, I start to have rooms that are further down the hall. So this is down the hall, and this is really far down the hall. And you can see that after a time, it might take less energy for me to go up to the next floor to a room right next to the stairwell, rather than go all the way down the hallway to fill up these rooms that are already kind of small and cramped anyway. So that's kind of the analogy of how you start to fill the 4S before you start to go back down to the 3D. So how do we put this all together? Our next video is going to talk about how the periodic table can be a magic document that enables us to predict what the electron configuration is going to be for its electrons.